Hey, today I'm going to show and explain the purpose as well as the fabrication process of the drilling template. First off, what is a drilling template used for? Put simply, a drilling template is a guiding aid for the surgical placement of dental implants. This is often necessary because, unlike with plaster models, a performing surgeon has a very limited view of the inside of the mouth and the respective operating area. The drilling template therefore ensures a precise placement. Up until a few years ago, there was only an analog method of production, but with the advent of computer-aided design and manufacturing, a new method with different advantages and disadvantages has emerged, which I will both show you today. The analog method starts with setting up placeholder teeth at the implantation area in a way that already closely represents the shape, size, relative position, as well as the occlusion of the ultimate implant or implants. To achieve this, the placeholder teeth are first slightly reduced to the approximate size necessary for a rough placement. For some leeway when first placing them, I use a soft sticky wax which remains malleable at room temperature. Once I'm happy with the initial placement, I use a different, harder wax to firmly anchor them in their place. And also neatly fill up the gaps between the placeholder teeth and the plaster model. This is then modeled to create a fitting tooth shape using the back end of a Lacron tool. Next up, we control the occlusion of those teeth in regards to their antagonists in the opposing quadrants and reduce the cusps where necessary in order to create the correct contact points. Let's see, that looks good. And we're down. Great. Before proceeding with the next step, it's sensible to block out narrow or fragile areas with more wax. And after we're done preparing the model, we're ready to create a vacuum-drawn thermoplastic template using this deep drawing device. We first put the model in a metal granulate, and after heating up a plastic foil, it is drawn over the model using a vacuum beneath it. This immediately draws it in place and also cools it down so that it keeps its shape after releasing the deep drawing mechanism. After it's cooled down, we can pull it off of the model and remove the placeholder teeth. And after we've cleaned the model with a high-pressure steam nozzle, we are ready to proceed with our polymer filling. The placeholder teeth have essentially left us with a cavity in the vacuum-drawn template, which will be filled in with a transparent two-component polymer. For that, the model is first isolated with an alginate solution, and afterwards the polymer powder and monomer liquid are blended together and poured into the vacuum-drawn template once the mixture reaches a gooey consistency. The isolated model is placed into the template, which pushes out the surplus polymer, and then everything is secured in place with plastic straps. Once secured, everything is placed into a pressure pot for 15 to 20 minutes, where high temperatures and high pressures speed up the hardening process and prevent bubbles from forming in the polymer. Yeah, that looks pretty good. After cooling down, the deep drawn template can be removed and the polymer teeth can receive their finish. For that, we start off by milling away all excess polymer. Yeah, good. And now let's check if they still fit. Yeah, great. Now, these next few polishing steps aren't that essential, but we'll proceed with them anyway to obtain a cleaner end result. We start off with a somewhat rough, lower grit polishing paste, which helps smooth out larger scratches or irregularities using a so-called Robinson brush. For a finer surface, we proceed with a goat hair brush using a fat-based high-grit polishing paste. And finally, we use a soft, tuft-like brush to remove excess paste and create a clean gloss. Now, because we're going to draw a second final template over these teeth, we need to add some retentions using a straight drilling head, so it all stays together afterwards. Now let's fix these polymer teeth back onto the model using a high temperature wax, and then we're ready to go. And so, after drawing another template, the teeth should now remain in the foil due to the retentions we added. And let's see if they do. Pulling out the model, and the teeth should stay in place. Great, they do. Now, for the final steps, we first cut off all the excess fall so we gain a better working angle. And using a marker, we trace the final extension we want the template to have. And then we simply cut it out with some scissors. We've now achieved its final shape, and all that's left to do is remove the tracer lines using some alcohol on a piece of soft cotton. It goes off quite easily. So, great result. In regards to the analog method, we're all done here. The template fits nicely, without gaps, and the performing surgeon will have a much easier time visualizing and ultimately placing the planned implants when he or she drills through the template in the patient's mouth. Now, with CAD/CAM, we proceed differently. Here, we first tell our program what exactly we want by filling out a patient file. Great. Once done, we start by successfully scanning each model, first on their own and then together, in order to document their relative position in the analog world. Here you can get a glimpse of the actual scanning process, which utilizes alternating stripes of light from several angles to create a depth map, which the program then reassembles into a consistent 3D model. Once recorded, we can digitally trim those meshes down to only the data we need, and then start the actual designing process. In its essence, this is no different to the placement of placeholder teeth in the beginning. The biggest advantage here, though, are the simple replacement and correction of their size and position. Everything can be repeated or corrected without surface abrasion or a loss in precision on the plaster models. And compared to our analog placeholder teeth, these are immediately going to be drilled in our final transparent polymer. Here, the designing process is coming to an end, and once we're happy with our design, the mesh is nested into an available blank. There we go. And it is sent over to our drilling machine. There, the blank and the necessary drills are placed into the machine and the actual milling process can begin. The design is carved out from the polymer blanks in a single step compared to the many we had to take with the analog method. While the drilling process isn't necessarily faster, the results are far cleaner and far more consistent than the analog method. Additionally, other things can be done while the machine is at work, which can be quite a time saver in the lab. Once the milling process is finished, the teeth are removed from the blank. The attachment points are smoothed out. Fits great. And again, we add some retentions on the sides of the teeth. Afterwards, the deep drawing procedure is the same as with the analog method. Here we can see the finished result, mostly indistinguishable from the analog method, but production-wise it's much simpler. Now, both methods have their validity under certain conditions, but from my experience, the latter method is becoming more dominant in the field. So I hope this provided you with a good introduction into the topic, and perhaps you could learn a thing or two from this tutorial. Thanks, and again, until next time. See ya!